Assalamualaikum and greeting to all. My name is Noor Asma Husain. I'm from UTM. So here I would like to present my research paper which entitled The Dynamic Scattering Coefficient on Image Dehazing Method with Different Haze Condition. The content outline consists of introduction, problem statement, objective, methodology, haze simulation, image dehazing method, result and analysis, and also the conclusion. For introduction, this research topic is related to the image processing field. Although image capture are usually influenced by light scattering and absorption from atmospheric conditions that are foggy, smoggy, and even hazy. This condition causes poor image visibility, low contrast, color, and so on. This situation is very challenging to computer vision, especially to recognize, track object, navigate, or surveillance. Hence, an image processing method called image dehazing is used in this research, which aims to remove the haze while at the same time maintaining the image quality. For the problem statement, most dehazing method can reduce the visibility of haze. However, the image result cause color distortion, oversaturation, and also halo effect. In addition, some methods only succeed in removing the haze to a certain level only. Therefore, a volume of various haze level is required to verify the dehazing method whether it is capable to remove haze at a variety of haze level. However, the existing dataset is insufficient to demonstrate the haze level that necessary to evaluate the dehazing method efficiency. So the objective of this paper first to identify the level of haze in the outdoor scenes in different atmospheric conditions. Then we simulate the synthetic haze in image based on the haze level identification to become a new haze dataset. The second objective to develop an enhancement of the single image dehazing method for removing haze at a variety of levels. And then the third objective is to evaluate the dehazing method for improving the quality of the image based on image quality assessment. The concept of this atmospheric condition is a medium between the camera and the object. Light scattering and absorption reduce the direct transmission from the object to the camera. Most of the dehazing method use the atmospheric scattering model as a basis of their approach. This model has two mechanisms which are light and also direct transmission. The equation as follows, where Ix equal to Jx dx plus A in bracket 1 minus Tx, where Ix represent haze image, Jx represent a haze-free image, Tx represent direct attenuation, and A is the A-like. Direct attenuation is formulated by the atmospheric scattering coefficients, the distance or depth of the scenes, the angle between the observer and the scene's object. The challenging part is to estimate the direct transmission because it is pretty difficult to measure the accurate haze thickness between camera and the object. So that is how the previous research proposed various methods on transmission map to get a better quality of haze-free image. However, this paper sticks to the original equation on estimate transmission based on the scattering coefficient value in the atmospheric scattering model. Okay, here is the methodology for the research. Okay. This process consists of two operations, which are the haze simulation process in the orange box and the image dehazing process in the green box. The first operation is to simulate synthetic haze. So the initial input must be a clear weather image. Then we put the default value of A-like and the transmission value based on the specified haze level. According to the atmospheric scattering model, we formulate the equation to produce 4 different levels of the haze image dataset. This haze image is used as the input haze image to the following dehazing process. Okay, for image dehazing process, first, gamma correction is applied to the haze image to control the brightness of the image. Then is the A-line estimation, and then estimate the scene's depth of the image. After that is the refinement to the depth, whereas the depth is the rough thickness. So the refinement or smoothing process is to enhance the precision of the depth. From the depth is to calculate the mean value. The mean value is mapping in the proposed visibility scale in this paper. The aim is to estimate the suitable visibility range for calculating scattering coefficient and transmission map. Okay, the values are formulated in the atmospheric scattering model to recover the haze image. After that, we enhance the appearance with contrast stretching to increase the image contrast. Then finally, we got the final haze-free image. Okay, here haze simulation to create clear image. Okay, for haze simulation, it is required to have a clear input image. To ensure the image is clear enough, we capture outdoor image with refers to Malaysian Air Pollutant Index. The weather condition must be in good category, where the index within 0 until 50. So this is the example properties of the captured image. We use actual distance to measure the depth. For the distance, we use distance calculator application based on the location map between camera and the farthest object seen in the image. Meteorological range. The level of weather condition is referred to this table. So this table shows the list of weather conditions, the visibility range and their scattering coefficients. This paper focuses on the haze range, so we simulate the synthetic haze image within 4 different haze levels, which are from dense haze in 1 km, medium haze in 2 and 3 km, and also light haze in 4 km. Here is a haze simulation algorithm. The highlight part is where the process managed to simulate 4 haze level and develop the haze dataset. These are the haze image based on the visibility range. So here we have dense haze for 1 km, haze for 2 and 3 km, and also light haze for 4 km. Okay, the following process is the image dehazing. So this is the algorithm for our image dehazing. This is the image dehazing algorithm that we propose. So the highlight part is the contribution in this paper where the process is dynamic dehazing because of the visibility scale. It measures the visibility the visibility range based on the mean value from the scene's depth. Okay, the range of the scale is approximately within 50 meter until 10 km as stated in meteorological range. We propose this scale which aim to dynamically allocate the visibility range value for the haze image. For example, if the mean value is less than 0.1005, then the visibility range is 10 km approximately, and so on. After that, the value is formulated in atmospheric scattering model to recover the scenes and produce haze-free image follow the image dehazing process. Okay, this slide shows the result of the image dehazing process. Okay, A for hazy image, B for scene's depth, C for depth refinement, D for transmission map, E dehaze image, and the last one F is image enhancement for contrast stretching. Okay, this paper compared our result with the other 5 dehazing methods. The DCP, which is the dark channel pyrometer, is capable of removing haze at all levels of haze. The sky, on the other hand, appears oversaturated. CAP, for color attenuation pyrometer, is an efficient way to reduce haze in a light hazy condition while still appearing natural. However, it was not successful in then haze condition. The image that result are still hazy. The dehaze net, the end result appears to be ideal for removing haze in all conditions while maintaining quality, especially in dense haze condition. However, in the hazy light condition, it was still at disadvantage compared to CAP. The haze light method result look over contrast and unnatural in all conditions. On the other hand, the MLT, multi-layer perceptual method, remove haze, but it appears to reduce contrast, making the image darker. So our proposed method show better natural appearance in all image results. By using image quality assessment, we show IMSE to calculate different error between the original. The least error is better. PSNR to estimate noise ratio and measure the image quality, and SSIM to measure the similarity index where the higher value is better match. As a result, the highlighted part show our result is produce image quality better than others. For the conclusion, lastly, I conclude that image dehazing is beneficial to many computer vision applications. The experiment of haze simulation and improved dehazing method is important to ensure the efficiency of the dehazing method to remove haze in different conditions and maintain the quality of image. Thank you very much.